Hello, my name is Alexander McMillan, and today I'm going to do my presentation on my bridge. So I'll have here my academic statement, the class, and so we'll get started. So some objects that we are going to be weighing today, so let me just move the screen sharing option out of the way, are a couple of books: Star Wars Thrawn, 7 Habits of Effective People, How Bad Do You Want a Book, a grade 11 textbook from my brother, 2 HP laptops, a medicine ball, a PS4, and potentially myself as well. So the items will also be shown in the video when I do the experiment. So the next one, we also have our weight of our bridge, which is 1.2 pounds. When we convert that, it is 1.2, sorry, not 0.55 kilograms. Some predictions I do have for this bridge is if we go back to the objects, although I have multiple objects listed, I'm kind of predicting that the bridge is going to fail or fracture or like fail internally, where on the HP laptop, where I think it worst case scenario or break out the textbook. Best case scenario, break out the laptops. If needed, I think the medicine ball will kind of finish the job. I don't think I'll need the extra PS4 that I have in my room or even myself stand on it. So right now we're going to videotape our bridge. I'm just going to do my couple of measurements that satisfy our bridge. So we'll go from one end of the deck first. We're going to go from up and down to the deck from unsupported span. So it has to measure from 400 to 100 millimeters. So as we measure from the ground up, you notice that the span over here on this measuring tape is above 100 meters, so roughly around 100 millimeters, 110 maybe. Then we go all the way over here, so now we're going to measure our deck span. So our deck span comes from all the way over here, from one end to the opposite end. We stop the tape, flip this around real quick. We have to get a measurement of over here, so that is sufficient in our range of 700 to 800 millimeters. Just do this way. Then we also have to measure our supports on the deck, which have to signify 100 millimeters to 110 millimeters. So we'll do that as well. So from the ground all the way up, deck is just about 100 millimeters, as so. Lastly, we have to measure the unsupported span underneath the bridge for different supports underneath. Roughly have to be at least 400 millimeters long. So I'm going to actually measure it from this end. Just make it a little more simpler for the camera. So you go from one end to the other. And it's roughly around, I would say, 540, 550 millimeters. Thank you. So right now we're actually going to explain the purposes of what I use to build a bridge. So for example, if we look at the two supports on the sides, both ends, these supports are 10 millimeters long and are extremely important in our bridge making. This is due to our supports being our support for our main structure over here. When the load is applied to the top, you have instant deformation over here in this big cap. We want to exploit that deformation, exploit the load of whatever I'm going to put upon into these supports. So the load goes here and goes across the bridge into these supports over here as well. So some design choices I also made other than the supports, making it nice and thick, which I technically played Jenga for a couple hours. Also notice, if you notice on the deck, it's not just one layer. It's multiple layers of popsicle sticks going this way, and also different layers of popsicle sticks of triangles in between. So triangles are a very strong shape, geologically and metaphorically, where when you use triangles to layer this up and we layer it, it made the bridge a little bit more thicker and a lot stronger to hold a little bit more weight in theory. When we flip the bridge over, you also notice I made some supports going from the side. So these supports are actually to support our support beams to the bridge. So as the load is applied on the bridge, it goes through these beams, that popsicle sticks, onto the support. So now, instead of deforming the whole bridge from these two supports to the middle, the deformation is a little bit slower. So instead of going down this way, that arc is a little bit smaller than before. Thank you. Hi, so we're actually going to do our test right now for our bridge. So I'm going to leave the bridge on the desk, which is parallel. as I mentioned, I'm going to use the 3 books over here as a start off weight, so that these weigh more or less kind of that starting position when we're going to start off. And then if it still holds, we're going to go through the Nelson textbook. One of my predictions is that I feel like that it'll break at the textbook. If it still doesn't break at the textbook, I'm going to use one of my broken laptops that doesn't work anymore, doesn't use it, and that probably will be the final weight of that bridge. If not, we'll probably get some other material and we'll keep it on and we'll see if it works. So right now we're going to do the 7 habits of highly effective people on it. Alright, it's holding pretty good. Now we're going to use this, the next book, like so. Now we're going to use a little bit book with a little bit more weight, which is Theron Ascension. As you can see right now, it's already starting to deform and kind of put like an edge on it. As you can see, it's already past deformation. The supports are already a little bit giving out. Okay, we're going to see right now if we can hold the textbook. I'm not 100% sure. I feel like it might could without the supports collapsing. We'll have to see. So we're going to gently put the textbook on. I mean, it's holding. So we're going to use, last but not least, I guess the HP laptop. I'm going to use the HP laptop. Put it on top. Still holding. We'll also have another material as well. I'm going to use also another broken stuff. I know I have a lot of broken stuff, John. Well, it's actually starting to really bend. So right now we've experienced a lot of plastic, like a lot of deformation. Sorry. Last, we're going to also use a PS4. Sorry, not a 5. As you can hear, you hear a little bit of a snap. Still holding though, kind of. So as it holds, I actually think it might have actually fractured. But right now it's still a little bit bendy. You can still see it's bending right over there. So it's still technically holding. One last one, at least we're going to use another laptop over here. And see if it holds this. If it holds it, and as you can see, it just broke right over here. Thank you. Hi, so we're back. So after we just crushed our bridge, some things I also noticed when feedback. So as I mentioned, I expected it to kind of break at the chemistry textbook, but I was very surprised that it actually broke or actually experienced what it's called deflection when the bridge kind of bends, and it keeps bending without fracturing. So as it keeps bending, right, really surprised that as the PS4 went on, as the final product went on, sorry, that's when they experienced it, not at the textbook. So I was actually really impressed with what I built. Experience the efficiency of structural capacity, which is that 9.48 divided by the bridge weight. So I did all the calculations except the medicine ball. The medicine ball and myself being on the bridge was I wanted to see when it would actually break, just for me as well too. Some things that I kind of would do differently is that I building truss systems. So I actually build example truss systems over here. The only thing is I didn't actually connect to the bridge because I couldn't actually make it stick effectively. Next time when I'm doing the project, for example, in March when we go, I will experience and use truss system because as I try to bend this, I'm trying to use my own hands to just bend it or just like move it, and it's very difficult. So this project has been really good on experiencing stuff that as something as a popsicle stick, one popsicle is weak just by itself, but multiple popsicle sticks together can build, and different materials can build wondrous things. Have a good day.